Okay, so question number 7 from the 97052 paper. Find the number of different arrangements of the 9 letters in the word Andromeda in which no consonant is next to another consonant. D, M, and R are consonants, and letter A, E, O are not consonants. That means vowels. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, sorry, E is not there. Sorry, E is not there. So these are just 5 consonants, and 4 are vowels. And also we have 2 A's and 2 D's. Okay, all right. So we have the arrangement A and D, R, O, M, E, D, A. So now we need to arrange them in a way that no consonant is next to another. So if we just simply delete the non-consonants, D, R, O, M, D, A. So A, O, E, A, for example. So A, O, E, A. Now, the places for the consonants, since they do not have to be next to each other, are this, this, and this. And we have 5 consonants to select from. So for the first one, we have 5 choices: 4, 3, 2, and 1. So this is just 5 factorial. And these vowels can be arranged 4 factorial ways also. So 4 factorial times by 5 factorial. Now we know that there were 2 A's and 2 D's, so we need to divide by the 2 factorial also, just to accommodate those possibilities where the duplicates are together. In that way, they are considered as one arrangement, not 2. So 4 factorial times by 5 factorial times by 2 times by 2, this is 720. Okay, all right, moving on. Find the number of different arrangements of 9 letters in the word Andromeda in which there is an A at each end and D's are not together. So when A's are at the end, so we have rest 7 places left to fill. So 1, 2, 3, 4, 5, 6, 7. So this means that out of those 9 letters, 2 have been already selected. So that means we just have to fill the 7 gaps now. So it's just 7 factorial, because we have 7 letters left, divided by 2 factorial. So this gives us the total arrangements when A's are at ends. We haven't considered the possibility of D's yet. So D's could be anywhere because we have 2 D's. So the divide by 2 accommodates for that. Now we don't want the D's to be next to each other. So to do that, we will consider the possibility when D's are together. So when D's are together, we consider them one unit. And when we consider them one unit, we have 1, 2, 3, 4, 5, 6 units together. Now, normally, we would have done the 2 factorial also, but since these are just these, they're duplicates, their internal permutations don't count because they will be just counted as 1. So it's just 6 factorial. So the total arrangements of Andromeda when there is an A at the end and D's are not together are just 7 factorial divided by 2 factorial minus 6 factorial. So 7 factorial divided by 2 minus 6 factorial, that is 1800. Right. Okay. 4 letters are selected at random from the 9 letters word in Andromeda. Find the probability that this selection contains at least one D and at least exactly one A. Right. Okay. So 4 out of 9 letters. So we have 1, 2, 3, 4. Right. So over here, since they have given us a condition at least one D, so we will have to go case by case when there's one D and when there are two Ds also. So if we list out the letters in Andromeda, so now when they say that exactly one A is being selected, that means one A is coming into this pool and the other A is not going to be selected. So automatically the two A's are gone. The two A's are gone. So that means next for the D's, we have to select from the pool of 7 choices. But also, so this is the case when we have one D and one A. So even for the D, we're going to do the same thing. So we are just selecting one D over here. So the keyword over here is selection. This is not permutation. So this means that this is a combination problem. So this will be, now two D's are gone, two D's are gone, two A's are gone. So this means that 9 minus 4, 5 letters are left. And we just have to select 2 places. And for either one of the A's, either one of the D's. So we have 5C2 times by 2C1 times by 2C1. We get 40. Now for the possibility when we have 2 D's and 1 A. So again, similar to what we did over here, we have 2 D's and 1 A already selected. So we just means that for the last place we have to select from a pool of again 5 people. Right, because 2 D's are gone, 1 A's are gone. So 5C1 multiplied by 2 of the D's, 2C2, and 1A, 2C1. So 5C, 2C2, and 5C1, that is 10. So these were the two possible selections, number of selections. Now the total selections, how many total selections we could have? Total selections. We could have we have total 9 letters. We just have to select for 4 of them. So 9C4. So 9C4. So that is 126. Now, since this was a question of probability, we will just do equals to 40 plus 10 divided by 126. So 50 divided by 126 is just 25 out of 63. Right, okay. So this question is done. See you in the next question.